Kia ora and welcome to this short video that goes through question 4B of the Schol Calc 2014 exam. We've chosen this question to do quite early because it just uses algebra. It doesn't use any of the content that you'll learn in Level 3 calculus. So try the question first. It's about combinations and factorials. And if you're struggling with how to work with factorials, Chapter 27 of Delta has some really good examples to do first. I'll do a couple as we get into the problem. So we've got this question. There are many integer solutions to the equation NCR equals n plus 1 CR minus 1, including n equals r equals 1. Find an expression for n in terms of r. So that really means make n the subject of the formula. Right, so we're going to be trying to get to that point, but we have a lot of work to do before we can get there. And hence find another of the integer solutions. Okay, so this equation here has got lots of solutions. One of them is when n and r is 1. N and r is 1 are both integers. So when n is 1 and r is 1, they're both integers. So our job is to find another one like that. Let's look at what NCR means again. When you learned about the binomial theorem, you might have been shown this way of writing it. So NCR means how many ways to choose R objects out of n, where I don't care about the order. They are also called the binomial coefficients, and they're the numbers in Pascal's triangle. Now that's all useful background, but we don't actually need to use Pascal's triangle to solve this problem. In fact, I don't think it's going to help us at all. What we're going to do is work with the definition of NCR, which is this. So NR, or NCR, which is how we usually say it, is n factorial divided by r factorial times n minus r factorial. So the first step in solving this problem is just to apply that definition to both sides and have a look at what we get. I'm going to do that on the next slide. So on the left hand side we have n factorial over r factorial times n minus r factorial, which equals n plus 1 factorial, so now I'm doing this side, divided by r minus 1 factorial. Now, be careful here, n plus 1 minus r minus 1 factorial. And that's simply applying the definition of combinations. Make sure that you do have this in brackets so that you remember that it's a minus a negative. Okay, so we're going to just pull down the left hand side again and simplify the very last term we wrote here like this. So n plus 1 minus r minus plus 1 factorial. So I'm going to replace this now with n minus r plus 2 factorial. Alright, now we need to look at properties of factorials, because it turns out that if we have, let's look at 9 factorial divided by 8 factorial. Now that at first doesn't look particularly beautiful, but all it really is 9 times 8 times 7, right down to 1, divided by 8 times 7, and so on. So that's just equal to 9. And we're going to use this property to simplify the expression, but not quite yet. So I'm going to go on to the next slide. Make sure you're keeping up with doing the working as we go. Okay, so we're starting out with this. whoops, made a mistake. Very, very easy to transcribe it wrong here. So it's n minus r plus 2 factorial. Now to be able to simplify, what we would like to have is the n bits together and the r-ish bits together and then these bits together. So we can do that easily. We just do some cross multiplying. I'm going to multiply both sides by r minus 1 factorial. I'm going to do this in several steps. I'm just thinking about how quickly to do it. On this side, the step I'll do now is this n here. I'm going to divide both sides through by that. So that's the first two bits of cross multiplying done, right? I've multiplied the r factorial over both sides, and I've divided both sides by the n factorial. Now the last one that I'll do is I've got an n minus r factorial here, and I've got an n minus r plus 2 factorial here. So we'll multiply both sides by this. So this side now becomes this. Now, actually, I'm looking at it. I did it a slightly more efficient way when I was working this out beforehand. But one of the things you're going to find with scholarship problems is often you do not find the most efficient way to start with. And sometimes it won't matter. Sometimes you'll go on a wild goose chase, and sometimes you'll go through a badly inefficient way, but you'll get there in the end. Okay, so one of the skills that you'll pick up as we go through the year is how to spot a better way into a problem. So what I'm going to simplify here is this and this, right? This and this, and I need another colour. Oh, there we are. This and this. We're going to do the easiest one first. So n plus 1 factorial divided by n is simply n. Okay, this is like 9 factorial over 8 factorial. R minus 1 factorial over r factorial leaves me with an r in the denominator. And here, this number is 2 bigger than this one. Okay, so I'm going to do the last bit here on the next slide. So we've got an r over here, and we've got n minus r plus 2 times n minus r plus 1, right? Because all the rest of the n minus r2 factorials, just looking at this bit again, are going to simplify out, because I've got n minus r plus 2, n minus r plus 1 times n minus r times n minus r minus 1, and so on the top line. And I've got most of that is in here. Right? So what I get left with when I'm simplifying this factorial is just the first two terms, so n minus r plus 2 times n minus r plus 2 plus 1. The rest you can cancel out. Right, so going back to the main equation, I've done my n minus r simplifying, I've done my r simplifying, and then on the other side I've got just n plus 1 left. So now the next thing we're going to do is cross multiply here. Now remember, my goal eventually is to find an expression for n in terms of r and then check for integer solutions. So this is starting to look much better because I've got an n here and an n here, so that looks like a quadratic. And that's an expression with n in it. So my highest power of n is 2. So I'm maybe starting to think about the quadratic formula. But let's have a look at what we get when we expand it out. Now again, there are efficient ways to expand it out and inefficient ways to expand it out. Doesn't really matter, just get going. If you want to try it a slightly more efficient way, you could put brackets in there, like that, but then you'd have to change that to a negative sign. Okay, so new slide to do the expansion. So we've got n minus r minus 2 times n minus r minus 1 equals n plus 1 r. So n squared minus r minus 2n minus r minus 1n plus r minus 2, r minus 1 is equal to nr plus r. So now we've got n squared minus n r minus 2 plus r minus 1 minus plus r. Now what I'm doing there is taking out the common factor here of the negative 1. So it's minus n times r minus 2 plus r minus 1. I'm subtracting nr from both sides, so that's here. I've got minus nr. And for the constant term in the quadratic, I've got r squared minus 3r plus 2 minus r. And so now that all equals 0. Now it still looks fairly awful, but actually we're getting towards a quadratic that we can do something with. So now I'm going to collect up all of those terms, so you can try that now. That's just the question come back. So collecting up those terms, I get n squared minus 3r minus 3n plus r squared minus 4r plus 2 equals 0. Alright, so now we've got this quadratic expression, and we've got a is 1, quadratic in n, b is equal to, we're going to switch this over to make it 3 minus 3r, and c is the rather yucky constant term, which is that. Now it's a constant term, it doesn't look like a constant term when you're used to level 2, but it's got no n's in it. R is just a number, so that is my constant term. Now off we go with our quadratic formula. So you can see we're going to get an expression for n in terms of r, which is a really good development. So it's going to be negative b plus or minus b squared minus 4ac on 2a, which gives me 3r, so 3r minus 3 plus or minus the square root of b squared, 3 minus 3r squared minus 4. A is just 4a times r squared minus 4r plus 2 divided by 2. Okay, so that's this. Oh, where's the pen gone? Here we are. Okay, so 3r minus 3, put down a denominator, plus or minus the square root of 9 minus 18r plus 9r squared, 9r squared, minus 4r squared, plus 16r, minus 8. Right, sorry guys, this is not exactly a work of art. 3r minus 3, plus or minus, right, collecting up like terms, I've got 5r squared from that one and that one, minus 2r, plus 1. Alright, believe it or not, we're probably about 3/4 of the way through the problem now. So what we're looking for, we've now got an expression for n in terms of r. But what we're asked to do is to find integer solutions. Now we're told that n equals 1 and r equals 1 is one solution. So we'll just check that that works here by having a wee look at what we get. So if we've got n equals 3r minus 3 plus or minus the root of 5r squared minus 2r plus 1 over 2, we can see that if we stick 1 in as r, we get 3 minus 3 plus or minus 5 minus 2 plus 1 over 2. And we can check that in fact that does give us here square root of 4 is 2. So we're going to get 3 minus 3, so nothing. So plus or minus the root of 4 over 2. Now you can see that the only root which is, hang on, not the square root of 4 over 2, square root of 2 over, the square root of 4, which is 2 over 2. So we get plus or minus 1. Now the negative solution makes no sense here, so we ignore that, and so we get our n equals 1. So that's what we started with. They told us that when r was 1, n was 1. We're not looking for the next solution that's going to give us that. So the only way to really do it is just to try values out and see if we get a perfect square under here. So let's go. If we do r equals 2, 5r squared minus 2r plus 1 is equal to 20 minus 4 plus 1, which is 17. So that's not going to give me an integer solution. So root 17 is not an integer. So let's keep going and see where we get to. Next slide. So r equals 3, 5 times 9 minus 6 plus 1 equals the square root of 40, so that's not going to work. R equals 4, we get 5 times 16 minus 2r minus 8 plus 1 gives me the square root of 73, also not an integer solution. R equals 5, so we're feeling quite bad at this point. We're hoping that we haven't made an algebra error. So 5, we get 5 times 25 minus 10 plus 1 is equal to 125, 115, 116. Nope, that's not a perfect square. And just as we're about to give up and go, I do not like this, 5 times 36 minus 12 plus 1 is equal to the square root of, well, 536 is 180 minus 12 plus 1 is the square root of 169. So we're delighted at this point because the square root of 169 is 13. So let's see what we've found. So when r is 6, n is equal to 3 times 6, 3r minus 3 plus, we'll put in the plus or minus, but we're not really interested in the negative root there, plus or minus the square root of 169 divided by 2, which is 15 plus 13 over 2, which is 14. So what we've found, we think, is that we're looking for when is nr equal to n plus 1 over r minus 1. So we think we've shown that 14c6 is equal to 15c5. And if you put them both into your calculator, you can check and you'll see that you get that they are the same, 3003. Okay, so that's the whole question. Break it into small steps, because scholarship problems come down to breaking up large questions into little chunks. One of the things that came up in here that you wouldn't have expected when you first looked at it was getting a quadratic and using the quadratic formula in a way that's a bit different to what we do in more algorithmic mathematics. Okay, so quadratic formula comes up in strange places, so keep a lookout for it in some of the other algebra questions. Thanks for watching, and please give me some feedback on whether this was any use at all. Thanks very much.